Hey everybody, we're here today to talk about how to deconstruct polynomials using division. And first we'll do a little refresher of long division. If we want to divide $583 among 6 people, we would probably want to know how much is everybody going to get. Is it going to go in evenly? Is there going to be anything left over? So we take the dividend, 583, and we'd divide it by the divisor, 6. 6 doesn't go into 5, but it does go into 58. That's 9 times. Okay, now we multiply and gives us 54. We subtract. It gives us 4. We bring down the 3. 6. The process now repeats. 6 goes into 43 7 times. We multiply and get 42. We subtract, and we're left with a remainder of 1. So this really tells us that everybody's going to get $97, and there's $1 left over, right? We could write this as 6 times 97 plus 1 equals 583. We could write 97 plus 1/6 as our result of the division, okay? And this one's going to be important, right? Whenever we divide and there is a remainder, we can always write that part that's left as a fraction, right? The remainder over the divisor, okay? So let's take a look at an example with polynomials. So we're going to go through a couple different processes here. First, we'll start with the long division. So we wanted to divide x cubed plus 2x squared minus 17x minus 10 divided by x plus 6. Okay. So we ask, what do we have to multiply x by to get x cubed? And the answer is x squared. That goes above the x squared term. We now multiply just like the regular old division. X squared times x is x cubed, and then plus 6x squared. Okay, we subtract, changing our signs, leading term disappears, and we have negative 4x squared minus 17x minus 10. The process now continues. What time? Negative 4 times, or negative 4x times x will give us negative 4x squared. Okay, and then when we multiply by 6, we have negative 24x. We subtract, change our signs. We have 7x minus 10. X goes into 7x 7 times. We multiply, we get 7x plus 42. Subtract, and we end up with a remainder of negative 52. So again, we can write that as minus 52 over x plus 6 here. Okay. The other way to do this is with synthetic division, right? With synthetic division, we're going to write the coefficients of our dividend. So in this case, 1, 2, negative 17, and negative 10. And then we're going to draw this L-shaped box. Now, whatever we're dividing by, synthetic division can be done with several different things, but it's easiest when you have a linear divisor, okay, like x plus 6. Since there is this multiplication, right, we multiply and then we subtract, right, 2 minus 6, right? We're going to account for that by thinking about the 0 of this, right, which would be negative 6. We're going to use that out here. So the 1 comes down. Negative 6 times 1 is negative 6. 2 minus 6 is negative 4, right? And that's this term right here. Now we multiply. Negative 6 times negative 4 gives me 24. We add, and we get 7. That's this term right here. Okay, so you can see where these different terms are coming from. Okay, and then negative 6 times 7 is negative 42. Boom, we get negative 52. So this provides a really quick way of knowing, of doing division with a linear divisor. Okay, again, this works with a linear divisor. All right, so you can try that. The area model can also be used here, right? We know we're dividing a cubic by a linear, so if I put my linear on the side, okay, I should be left with a quadratic. Okay, now I know I'm going to have x cubed, 2x squared, negative 17x, and negative 10, right? Got that along the outside. So the one I can start with is x cubed. Okay, now x times x squared gives me x cubed. Now that I know that, I can multiply the 6 by x squared to get 6x squared. Along the diagonal, it should have up to be 2, but we have 6, so we need to have negative 4 here. So it's negative 4x squared. All right, now, what times x gives us negative 4x squared? Negative 4x. We multiply by the 6 now to get negative 24x. Okay, along the diagonal, it should add up to be negative 17x. so we have to have a positive 7x here. Okay. What multiplies? 7 does, and then 7 times 6 is 42. Okay, so how much higher, right? I have to account for that, right? That this is extra. So I have to take that negative 10 and subtract out 42 to get my negative 52. It's one of the more confusing parts about using division here, is what do we do when it doesn't come out evenly, okay? So let's take a look at example number 2. All right, for this one, we're going to go straight to doing synthetic division. All right, so I'm going to have 1, 9, negative 7, and negative 63. Okay, again, I can do synthetic division because we have a linear divisor. I'm going to use negative 9 out here. Bring down the 1, we multiply, we get negative 9. Add vertically, we get 0. Multiplying, we get 0. Adding, negative 7. Multiplying, we get 63. And when we add, we end up with 0. Okay, so this one goes in evenly, right? What it actually tells us is that this cubic can be written as x plus 9 times whatever's left over. And that's this right here, right? This is our x squared term, this is our x term, and this is our constant term, right? Our number. Okay, so we're going to have x squared minus 7 here. Okay, and if we wanted to, we can continue to see where that goes, right? If we go ahead and try out the area model, okay, again, we have this cubic divided by a linear, so we're going to end up with a quadratic at the top. Here's my x plus 9. I'll have my x cubed, 9x squared, negative 7x, and negative 63. Okay. So we know we could put the x cubed in there. X times x squared is going to give me x cubed. Now I go through 9 times that, 9x squared. All right. Well, hey, it already is that, so we have 0x squared here. 0 times that, boom, 0x. Okay, and so then we end up with 0x. Okay, those should add up to be negative 7, so this has to be negative 7x. This tells us that has to be negative 7, and we multiply, we get negative 63, which is what it is, right? So since these ones come out to be the same, right, it tells us that we got it correct. Again, we can rewrite this as a product. Now, what I like about this is that the product is already there. X squared minus 7 times x plus 9. We don't have to guess. We don't have to do anything weird with switching to a negative or doing anything like that. So when it comes out nicely and it comes to factoring, the area model provides us with a nice model. So what about when it's not a linear factor? Okay, again, there's a way to do synthetic division with this, but we're going to have to do some long division or the area model. So x minus 1, we can't divide like that. We have to multiply that out. Okay, so we know we're going to get x squared minus 2x plus 1. Okay, so our dividend is 2x cubed minus 2x squared, and we have to add a place for the x, so we're going to add 0x here. Okay, divided by x squared minus 2x plus 1. Now the process is going to be the same, okay, except now we're going to focus on the x squared. What times x squared gives us negative 2x cubed? 2x cubed, that's going to be 2x. So we write that over the x term. Now we multiply. We're going to get 2x cubed minus 4x squared plus 2x. We subtract, changing our signs. We end up with 2x squared minus 2x. Bring down the 1. Well, 2 times 2x squared. So we get 2x squared minus 4x plus 2. Subtracting, we end up with 2x minus 1 for our remainder. Okay, so we're going to go ahead and rewrite that as minus 2x plus 2x minus 1 over x squared minus 2x plus 1. Okay, and that would be our result of the division. Now again, we can use the area model here. This time we're dividing a cubic by a quadratic, so what's going to be left is a linear at the top. Okay, so we're going to set it up a little bit differently. All right, but we're going to have 2x cubed minus 2x squared, 0x, and 1. Okay, and we can put our x squared minus 2x plus 1 out here. So our 2x cubed goes here. Okay, we know we're going to multiply by 2x to get that. Now we can multiply down. 2x times negative 2x is negative 4x squared, and 2x times 1, which is different than before, right? We want to multiply by everything that's here. All right, now, this diagonal should add up to negative 2x squared, but we got this negative 4. We've got to add 2x squared here, which means multiplying by x squared, this has to be 2. Okay, it's got to be positive 2. Okay, now when we multiply here, we know that what we should get is 0, but man, in this column, but we're going to get negative 4x here and 2. Okay, so that when we add these, well, we've got negative 2x and positive 1, right? That it's over, right? We're over negative 2x. We're over, by 1. Okay, and so to account for it, like the last one, we had to subtract. So again, when it doesn't go in evenly, that's the hard part of how do we get to that remainder. Okay, so again, pros and cons. Synthetic division works really well when we have a linear divisor. Okay, the area model works really well when it is a factor and it goes in, right, and it tells us what's left over. And long division will work either way. So try those out, try the different models, and again, have those tools ready to use, especially when it comes to the last section on factoring.